Hello everyone, welcome to Aviation Engineering YouTube channel. Alright, today I took EASA Part 66 Module 1 Mathematics lesson number 4 for you guys. So if you still not watch my previous videos regarding EASA Module 1 Mathematics, I will put the card in up here. You can see this is the playlist, so you can go and see the videos. I do the arithmetics numbers, right? So you can watch these videos and then come to here. This is the lesson number 4. So if you still not subscribe Aviation Engineering YouTube channel, please subscribe. Please share these videos with your friends, and after you finish this video, if you like this video, please hit the like button. All right. And also, if you want to get more notifications, please click the bell icon. Then when I upload the video, you will get the notifications. All right. Okay, so now let's go to the lesson. All right. Okay, so today I'm going to teach you EASA Module 1 Mathematics, lesson number 4, Geometry. All right, so the lesson contains angular measurements and geometric constructions, and also area and volume. So this lesson will be a little bit longer, so stick with the here. So don't be boring. If you're boring, so you stop and then you continue the next day, right? So because I don't want to make this one very two parts, so that's why I want to make it long lesson, so you can watch this later. All right, so okay, let's go. So the first one, angular measurements, right? So you can see this is an angular measurement. Okay. All right. So angular measurement is about measuring how much something has turned or where it's pointing. All right. So we use degrees. So normally we use degrees, like a full circle being 360 slices. Okay. So for angular measurements, we are using degrees. So there are also radians, right? So they have two kind of measurements we are using. One is degrees and also radians, like 1 radian being the angle of a slice with the same length as the circle's radius. Okay, so about the radius we will talk later. So the gradients are like degrees but split a bit differently. Okay, gradients are like degrees but split a bit differently. We need these measurements in fields like astronomy and engineering to understand directions and rotations. Okay, you can see here, right? The terminal side, here the initial side, here the vortex, right? This is the measuring angle. All right. Okay, so now here, see, you can see the two lines. So if two straight lines are drawn, okay, if two straight lines are drawn, we can see that they make an angle. Okay, you can see here there's two straight lines drawn, then we can see they are here make an angle. So but how are angles expressed and measured? Okay, two straight lines there, we can make angle, but how angles express or measure? So consider a single line and rotate it through the complete revolution. Okay, here is a single line. We will rotate the complete revolution. You can see here. So then the angle that this line has turned through this 360 degrees means if we start from here and if we turn like this, and the angle is full circle 360 degrees. So a degree is 1 degree. Okay, 1 degree is 1 upon 360. Remember, 1 degree is 1 upon 360 of a revolution. All right. Okay, so note that half a revolution is therefore 180, and the right angle is 1 upon 4 of a revolution is 90 degrees. Okay, remember, half a revolution means this one is goes to here, so then the angle is 180 degrees, and the right angle is over there, right? Right angle 9 o'clock or 3 o'clock. Right angle here is, you can see this is 1 upon 4 of revolutions, that means 90 degrees. All right, so here is the right angle 90 degrees, is 180 degrees, half an angle. So note that 1 degree can be subdivided into 60 minutes. Remember again, 1 degree, okay, 1 degree can be divided into 60 minutes, and 1 minute can be subdivided into 60 seconds. Remember, 1 degree we can subdivide it into 60 minutes, and 1 minute we can subdivided into 60 seconds, right? So that is the way, that is the flow, right? Okay, so now you can see right here is the 0 degree angle. Okay, here is a 0 degree angle, right? So then the acute angle is less than, the angle is more than 0 degrees, less than 90 degrees. Okay, here you can see, and right angle is the angle is equal 90 degrees, and the obtuse angle is the angle between it is like obtuse angle is more than 90 degrees and less than 180 degrees. So the straight angle over here, you can see it is 180 degrees, and the reflex angle is more than 180 degrees and less than 360 degrees, and the full rotation angle is equal 360 degrees. All right. Okay, you can see the opposite angles. A and B are the opposite angle, we will discuss later, and the complementary angles, A plus B is 90 degrees, and adjacent angles and supplementary angles. Okay, all right. Right, so a few definitions are included here, right? So an acute angle is less than 90 degrees, and obtuse angle is between 90 degrees and 180 degrees, and reflex angle is greater than 180 degrees, and the complementary angle is their sum of 90 degrees, and the supplementary angle is their sum is 180 degrees. All right. Okay, so now the angle associated with parallel lines. So now consider two parallel lines cut by a transversal. Okay, you can see there are two parallel lines, and this one cut by the transversal. Okay, you can see. So now the angle A equals C, right? Here the angle A equal angle C, and the angle B equal angle D. So they are opposite and equal. Remember, these angles are opposite and equal. Similarly, L equal P and M equal Q. So also A equal L. Okay, the angle A equal angle L, and D, okay, D equal Q, etc. like this. Okay, so now they are the corresponding. Okay, you can see A equal L is corresponding angles, and A equal C is opposite and equal angles. Okay, so now you can see the corresponding angles are A and L. So now you can see D equal L, D and M. D and M also equal, right? D and M also equal. So then, and also C equal L, C equal L. So they are alternate angles. Remember, corresponding angles are here, and the alternate angles are like this. So, and also D plus L equal 180. Okay, you can see, right? If you add D and add L is 180 equal C plus M. So these are interior angles. Okay, these are the interior angles. All right, and the supplementary. Remember, these are the interior angles and are supplementary. Okay, just remember. Okay, now let's go to the number 2, geometric construction. Okay, geometric construction. All right, so under geometric constructions, I'm going to teach you about the triangle, similar and congruent triangles, and polygon shapes, and quadrilaterals, parallelograms, rectangle, rhombus, square, and trapezium, and circles. Okay, let's go one by one. All right, so now let's go to the first one, the triangle. You know about the triangle, right? Here, the triangle is very basic, right? So a triangle has a shape with 3 sides and 3 corners. Okay, a triangle have a shape with 3 sides and 3 corners. So call the angles. Okay, these corners are we called as angles, and we label the side as A, B, C. These are the simple A, B, C are the sides, and the angles are capital A, capital B, and capital C. So now the neat thing is no matter the size or shape of the triangle. No matter the size or shape of the triangle. Okay, no matter the size or the shape of the triangles, the sum of these three angles, the sum of these interior three angles, always 180 degrees. Remember, in a triangle, no matter the size or the shape of the triangle, the sum of these three angles is always 180 degrees. So that means if you add up the angle A, okay, sorry, not there's no double A, just A. If you add up angle A and angle B and angle C, you always get 180 degrees. Okay, just remember, right? If you always add angle A, angle B and angle C, you always get 180 degrees. It's like a rule that all triangles follow. Okay, and no matter what, this helps us understand how triangles are put together and how they behave in different situations. All right. Okay, now you can see you have a triangle ABC. You have a triangle ABC. Now, if you extend one of the sides, let's say BC, right? Now you're going to extend BC side a little bit more, you can see, and draw a line parallel to another side. Okay. Okay, now first you like you can see ABC triangle over there, and you extend BC a little bit, and then draw a line parallel to another side. Okay, now we will draw a line parallel to AB. We will draw a parallel line, right? Let's say AB from the opposite corner. Okay, let's see AB from the opposite corner. We write. Now you end up with two angles. Okay, now you end up with two angles. There are two angles, right? AB, right? These new angles when added to the x16 angle B. Okay, these new angles when we added to the x16 angle B, always total is 180 degrees. Okay, new angle, these new angles when added to the x16 angle B, right? I think it's wrong, right? This is not B. When these angles when added to the existing angle C, okay, existing angle C is always degrees, always is like B, always the total 180 degrees. All right, so it's like a puzzle where the piece always fit together perfectly. No matter how you move them around, this helps us see why the angle in triangle always add up to 180 degrees. Okay, so and also when you want to get the area, we will talk later, the area of a triangle is half into base into vertical height. All right. Okay, now let's go to triangle sides. There are so many triangle types. You can see acute angle. Acute angles triangle means has all of its angles less than 90 degrees. Okay, it means acute angle, all the triangle the angles are less than 90 degrees. And the obtuse angle, you can see this is the obtuse angle. Triangle has one angle greater than 90 degrees. Two angles are less than 90 degrees and one angle is greater than 90 degrees. And the scalene triangle, you can see where is the scalene. A scalene triangle is that has one of its angles equal to 90 degrees. Scalene triangle, one of its triangle has three sides of different lengths. Scalene triangle, the sides are different sizes. Okay, and the right angle triangle has one of its angle equal to 90 degrees. Here is the right angle, one is equal to 90 degrees. The longer side is opposite the 90 degrees angle. Always the longer side, okay, always the longer side is opposite to the 90 degrees angle, right angle, and is called the hypotenuse. This is called as a hypotenuse. Okay, so isosceles triangle has two sides and two angles equal. Isosceles triangle has two sides and two angles equal. When isosceles triangle, two angles are equal and two sides are equal. The equal angles lie opposite to equal sides. And the equilateral triangle, you can see equilateral triangle has all its sides and the angles equal. And has all sides and angles are equal. In equilateral triangle, angles and the sides are equal. All right. Okay, now we'll go to the similar and congruent triangle. Similar and congruent triangle. So we'll get to know what is similar and congruent triangle. So you have two triangles. Now you can see you have two triangles. If their angles are the same, right? You have two triangles and their angles are the same, even if their sizes are different. Okay, you can see this is two triangles. The sizes are different, right? this triangle is smaller than this triangle, but size are different. We call them similar triangles. But even the sizes are different, we can call them as similar triangles. So if you have a small triangle and big triangle, but their angles match up, they are still considered similar. Okay, remember, if you have big triangles and a small triangles, but their angles are same. Okay, it means A equal A, simple A equal capital A, simple C equal capital C, simple B equal capital B. They are still considered as similar. So it's like comparing two drawings of a house. One might be bigger, but if all the angles are the same, they are still picture of the same kind of house. Okay, right now you can see here, if you have two triangles that look exactly the same and have side of the same length, okay, we call them congruent triangles. Remember, if you have two triangles that look exactly the same and have sides of the same length, we call them congruent triangles. It's like having two cookies that are exactly alike in shape and size, so they are congruent. Okay, remember, the congruent triangles are same sides and same length. Okay, exactly the same and have sides of the same length. Okay, all right, here the congruent triangles. Okay, you can see side this triangle side equal to this angle triangle, and this side equal to this side, and this angle equal to this kind. So this angle, these triangles are congruent triangles. All right. Okay, now the ways to find the triangles are congruent. Okay, there are some ways to find the triangles are congruent. So the first way is the side SSS rule, side. So it means if three sides of one triangles are the same length, if three sides of one triangle are the same length as a corresponding side of another triangle, then the triangles are congruent. It means, okay, this is, okay, we will call it as number A triangle, this is number 2 triangle, number 1, number 2, and number 1 triangle BC axis, BC side is equal to number 2 triangle XY triangle. All right, XY side. So like this, you can see if the three sides of triangles are the same length as the corresponding side of another triangle, then the triangles are congruent. So then these two triangles are congruent. It's like if you have two sticks and they are the same length as two other sticks, and those sticks are the same length as each other too. This is called side. It means three sides equal to the, they have two triangles, one triangle side is equal to the corresponding other triangle side, so then they are called congruent. And next one is angle, side angle, ASA. So if two angles and the side between them of one triangle are the same as two angles and the side between them of the triangle, another triangle, then the triangles are congruent. Remember, angle, side angle means if there's a two triangles and two angles are equal as the other triangle and one side is equal, then we call it as angle, side angle, congruent triangles. Okay, so then the triangles are, in this situation also the triangles are congruent. So it's like if you have two angles and a piece of string, they are exactly the same as two angles and piece of string from another shape. Now let's go to side angle, side angle, side SA. So it means if you two sides and angle between them of an one triangle are the same as two sides and the angle between them of another triangle, then the triangles are congruent. In this situation also we call it as triangles are congruent. So it's like if you have two sticks and angle and they're exactly the same as two sticks and an angle from another shape. Right, so the right angle hypotenuse side. Okay, right angle hypotenuse side. Okay, you can see this is the hypotenuse, right? I told you the opposite side of a right angle triangle, opposite side of the right angle triangle. Okay, yeah, right. So if the hypotenuse and one side of a right angle triangles are equal to the hypotenuse and the corresponding side of another right angle triangle, then the triangles are congruent. In this situation also triangles are congruent. So it's like if you have a right angle triangle and the longer side and one of the other sides are the same length as the longer side and one of the other side of another triangle, then they are match up perfectly. Okay, you can see they have two right angle triangles and the hypotenuse are same, and here also same, and the right angle also same, then these two and triangles are also congruent, right? All right, so now let's go to the polygons. So polygon is just a closed shape made up of straight lines. Polygons we will call as polygons as a closed shape made up of straight lines. You can see all the shapes over there are made up of straight lines. So the word poly means many. Poly means many. So the polygon has many sides. Polygon has so many sides. So triangle is the simplest polygon because it only has 3 sides. Now the other polygons have the names that tell us how many sides they have. For example, a 4-side polygon is called the quadrilateral, a 5-side is a pentagon, and so on. So basically the name of the polygon tells us how many sides it has. Okay, you can see the triangle 3 sides, quadrilateral 4 sides, pentagon 5 sides, hexagon 6 sides, and the heptagon 7 sides, and octagon 8 sides, nonagon 9 sides, and decagon 10 side shapes. Okay, we can make it more, right? Yeah. Now the quadrilateral, we'll go to the quadrilateral first. The quadrilateral is just a shape with 4 sides. Okay, quadrilateral as a shape with 4 sides. Okay, you can see that quadrilateral, there are 4 sides. And now there are different kind of quadrilaterals. They have so many kinds of quadrilaterals. Some you might know well, like squares also quadrilaterals, rectangle also quadrilateral, because they have 4 sides. And other might be less familiar. This kind of shapes less familiar, right? So here's something cool about quadrilaterals. You can always split them into 2 triangles. Now remember, if you have quadrilateral, if you know about the quadrilateral, you can split this quadrilateral into 2 triangle always. This is like a cool something like special thing, right? So because of this, the angle inside the quadrilateral will always add up to 360 degrees. Okay, remember why? The triangles are always 180 degrees. So if there's 2 triangles, is 360 degrees. So that's why the angle inside the quadrilateral always add up to 360 degrees. It's like a rule that all quadrilaterals follows. Okay, remember. Now the parallelogram. Parallelograms, you can see here is also a parallelogram. It's also like a quadrilateral, right? So parallelogram is a special kind of 4-sided shape where opposite sides are parallel. Okay, opposite sides are parallel. Here are some things that are true about parallelograms. Okay, right. So equal in parallelogram they have like equal. This is also parallelogram, special kind of 4-sided shape where opposite sides are parallel. You can see the opposite side. This side is parallel to this side is parallel to this side. So there are some things that are true about parallelograms are here. The equal side lengths, always the length of the sides are equal. That's why you can say here, right, all the sides are equal in length, and the opposite side of the parallelogram have the same length. Okay, opposite side of the parallelogram has the same length. So the equal angles, you can see this angle equal to this angle equal to this angle. And the diagonal properties. Okay, diagonal means the diagonal lines connecting opposite corners of a parallelogram bisect each other, meaning they split each other into 2 equal parts. Okay, you can see here like this. And the diagonals also bisect the parallelogram itself, splitting into 2 congruent triangles. Okay, when you divide this one into like this, you can have a 2 congruent triangles. Okay, so in parallelogram, opposite side and the angle match up, and the diagonals create equal piece inside the shape. It's like a special kind of puzzle with lot of equal parts, right? Okay, now let's go to the rectangle. Here is the rectangle. You know about the rectangle. So the rectangle is a special type of parallelogram where all angles are 90 degrees. Okay, rectangle is a special type of parallelogram. All angles are in 90 degrees. You can see A is 90 degrees, B is 90 degrees, C is 90 degrees, and D is 90 degrees, making out like a square stretch out. Okay, a square, we can you can see the square is like this, and when we stretch out, it's like a rectangle. Now a rectangle has all the properties of a parallel. Rectangle also have all the properties of the parallel, such as opposite sides being equal. This AD equal to BC, and AB equal to BC equal, and opposite angles are being equal. All the right angles, so definitely the all angles are equal. But there's something extra special about rectangle. It means the diagonal of the rectangle are not only bisecting each other, but also they have the same length. Remember, the diagonal of the rectangle. The diagonals of the rectangle are not only bisecting. Diagonals of the rectangles are not only bisecting each other, but they also have the same length. Okay, it means DB equal to CA. That is a special extra special thing, right? So you can think of rectangle as a super special parallelogram. Okay, this is also a super special parallelogram where all the angles and right angles and the diagonals are equal. So it's like a perfect shape for making boxes and rooms, right? Okay, now let's go to the rhombus. Yeah, here is also, you can see this is the rhombus. So the rhombus is a special kind of parallelogram. Rhombus also a special kind of parallelogram where all the sides have the same length. In the rhombus also, remember, all the sides have same. Remember, in the before I told you about in the rectangle only the opposite sides are equal, but in the rhombus all sides are equal, same length, and the square, that means stretch out. It means if you have a square, if you stretch out, it look like rhombus. Now, just like a parallelogram, a rhombus has opposite sides and that are equal and opposite angles that are equal. Okay, it means opposite sides are equal, or definitely four sides are equal, and the opposite angles are equal. You can see this angle to this angle equal, and this angle to this angle so equal. So but here, what's the unique about rhombus? What is the unique about rhombus is the diagonals of a rhombus. You can see the diagonals of the rhombus are not only bisecting each other, but they also meet at right angle. Remember, the rhombus, they are not only bisecting each other, they make right angle. Okay, right, they also meet a right angles. So you can think of a rhombus as a super special parallelogram with equal sides where the diagonal create right angles. Is like a diamond shape with all its sides equal. Okay, this is a rhombus. Now let's go to the square. The square is a super special kind of rectangle where all the sides are equal. Okay, square also super special type of rectangle where the all sides are equal and make it look like a stretch out of rhombus. So the opposite side, as I told you before. Now, just like all these shapes square has, the opposite side and equal and parallel. Opposite sides are equal and in parallel, and the opposite angles are equal. Remember, opposite angles are equal, always right angle, and diagonals that bisect each other at right angle. Okay, if you have bisect each other, then you can make a right angle. So you can think of a square as the ultimate shape. It's like a superhero shapes because it has all the cool properties of a parallelogram, rectangle, and rhombus. Remember, square has all the properties of parallelogram, rectangle, and rhombus. This is a combination. Okay, that's what we call as superhero. Alright. Right. Now let's go to the trapezium. Trapezium here. So the trapezium is four-sided shape. That's also yeah, right. Sorry, trapezium is a four-sided shape. So just like a rectangle or square, this is also same like a rectangle square, but it is a special because it has one pair of sides. Okay, it has one pair of sides that are parallel to each other. Okay? Remember, in trapezium, they have in trapezium there has a one pair of sides that are parallel to each other. You can see in trapezium there are one pair of sides parallel to each other. So that is it. It's like having a shape with one set of train tracks. So it's like quadrilateral. It is also quadrilateral, but with one pair of sides running alongside each other. Okay, you can see. Remember, the trapezium, one side is two sides are in parallel each other. Okay, all right. Now let's go to the circle. Right, circles. So the circles are not just a perpendicular mathematical shapes, right? Circles are not just a perpendicular mathematical shapes, but are involved in our everyday life. For example, like wheels are circles, gears also circles, and basically circular and shaft revolves in circular fashions. Okay, because circles very important to our life. Right, so hence we must be aware of some important definitions and properties. Okay, so if the line OP, you can see if the line OP is fixed at O. Okay, OP line is fixed at O and rotate around O. The point P traces a path which is a circular, forms a circle. Okay, if there's a line you can see here, and here is the point O, and it is rotate around O, then you can make it a circle. So the length of OP, is radius. Okay, remember the length of OP is the radius of the circle. Length of OP is the radius of the circle. Note that OP equal OA equal OB, because the same, it is a radius. That the length of the line AB is 2OB, right? The length of the AB is clearly equal to twice the radius. Okay, so AB is the twice the radius. It means AB equal to OP, and AB is the diameter of the circle. Remember, OP is the radius and AB is the diameter. So the diameter equal 2 times radius. Okay, you can see the picture over here, circumference. Okay, right. So when the point P is the circle around the fixed and path, but how far does it travel? Right. Okay, let's see how far. You can see this one, how far does it travel. So imagine a wheel rolling along the ground. Imagine the wheel. Okay, imagine the wheel rolling around the ground. If the radius of the wheel is r, okay, the radius of the wheel is r, then the distance is roll in 1 revolution. Okay, it means the radius of the wheel is r, and if it is revolute 1 revolution, how much this wheel rotate to, how much distance does it travel? Okay, so then distance is roll, 1 revolution is the circumference, is the circle is made. So we can calculate this circumference using the formula C. Circumference equal 5 into D. 5 where the D is the diameter. Okay, D we can call it as diameter into 2 OP of the circle. Since the diameter is twice the radius, so we can also write it as 25 into R. 25 into R. So now the 5 comes as 5 is a special number that represents that the ratio between the circle circumference and its diameter. Okay, remember the 5 is a special character, a special number that represent the ratio, between the circle circumference and its diameter. So it's approximately 3.142, although it goes on forever without repeating, so you'll find it on a specific calculator as a fraction of 22 upon 7, so which is a very close approximation, right? So if you know the radius or diameter of a circle, you can use 5, right? If you know the radius or the diameter, if you already know the radius or the diameter, you can use 5 to figure out how far it travels when it is rotated the rods, right? Okay, you can see the line AP here, the line AP, so that it is touches the circle at point P. Okay, the line AP touches the circle at point P is known as a tangent. Okay, we will talk about the tangents later. So to the circle, this is a tangent to the circle, right? It should be noted that AP always, right angles to the radius OP, right? Okay, so now we will go to the some example. So a wheel diameter 715 millimeters, makes 30 revolutions. Okay, 30 revolutions, right? A wheel diameter is 750 millimeters and it makes 30 revolutions. How far does it move from its start point? So first, okay, you can see here is the wheel. The diameter is 750 millimeters and it takes 30 revolutions. So now they're asking how far does it travel. So now first we find out how far the wheel travels in 1 revolution. Okay, now first we need to find how far the wheel travels in 1 revolution, which is the circumference of the wheel. We use the formula circumference equal 5 into D, right? So where the D is the diameter of the wheel. So that given that the diameter of the wheel is 750 millimeters, we can calculate the circumference equal 5 into 715. So 5 we know 3.142 approximately. So then we can calculate as 5 as equal 3.142 into 750 millimeters. Approximately we will get the circumference is 2248.03 millimeters. Okay, so now in 1 revolution the wheel travels approximately 2248.03 millimeters in 1 revolution. So now we had to calculate how many does it travel, how many millimeters in 30 revolutions. So then now you find out how far it's moved in 30 revolutions. So we simply multiply the distance in one revolution by number of revolutions. So now the distance in 30 revolution is 2248.003 into 30. So then you will get 67,440.9. So the distance in 30 revolution is approximately 67.4 meters. Okay, because this value is from millimeters, so then we have to make it to meters. So the wheel moves approximately 67.4 meters from its starting point. Okay, the distance is 67.4 meters after 30 revolutions. That is very easy. Now the radian measures. Now we go to the radian measures. So we'll already know that the angle of 360 represents one complete revolution. Okay, so but there is another important unit of angular measurement known as radian. Okay, angular measurement we known as radian. So you can see one radian. Okay, one radius r radian. So the consider a circle of radius r and the consider an arc AB where the length is also equal to r. AB arc length is equal to r. The angle at the center of the circle AOB is then equal to 1 radian. Okay, radian we will call it as the radius is r, and you can make an arc like this. Okay, OB also r, OA also r, then arc RAB, the arc AB also r. In this kind of angle, this angle is also we call as 1 radian. All right. So now imagine you are walking around a circle, right? Now imagine you are walking around a circle. One full circle is like walking 5 times around the circle. So that's the same as saying one full circle is 6.2832 radians, okay? Because the 5 is 3.142, right? So if you want to convert between degrees and radians, you can use those conversion factors, right? You can convert the degrees into radians and radians into degrees. So to go from degrees to radian, 1 degree is about 0.01745 radians approximately, and to go from radians to degrees, equal 1 radian is about 57.3 degrees approximately. So degrees and radians are just two different ways of measuring angles, like using inches and centimeters for the lengths. Okay, this is the degree and the radian measuring conversions. You can see from degrees to radian, when you want to convert degrees to radian, the number of degrees multiplied by 5 divided by 180 degrees, and from radians to degrees, you can say number of radians into 180 degrees over 5. All right, so this is the normal calculation formula. All right. Okay, now the one final and useful point for considering radian measures. Okay, you can see R 5 angle, P arc length. So if an arc of a circle radius R subtend an angle equal to 0 equal to theta radians, right? Okay, see the theta radians, the nth of the arc is r into theta. Remember, if an arc of a circle, here is the one arc of a circle, radius is r, the subtend an angle, this angle is equal to theta radians, the length of the arc we can call as r into theta, r into angle, radius into the angle made from it. So note also that if a point, so this formula is very important, right? So note also that if a point P is moving with the speed n, right? If a point P is moving with the speed of n, then the rotational speed, it means angular velocity, is equal to r into n divided by r squared. Okay, r into n divided by r squared. So then the n equal, right? So the speed, you can calculate the speed equal r into rotational speed. Okay, r into the angular velocity, or as r into rotational speed. All right, we will talk about rotational speed, angular velocity in the physics lesson. So the angular velocity is expressed as radians per second. Remember, angular velocity we will express as radians per second. All right. Okay, now let's go to the third one, last one, area and volume. Okay, you can see the area and volume. So now we'll go to the area. So imagine you are laying down a carpet in a room. So if you only know that the length of the room, you won't have enough information to buy the right amount of the carpet. So you also need to know how wide the room is, right? Okay, now you also want to know how wide the room is. So that's because the carpet covers the surface, not just a straight line. So when we talk about how much carpet you need, we are not just talking about the length, right? We are talking about the space it covers, right? We are not talking about the carpet length. We have to calculate how much space it covers, both lengthwise and width wise. So this two-dimensional idea of size, where we consider both length and width, is called the area. Just remember this one. So this dimensional size, I mean length into width, is called as area. So it's like measuring the space inside the shape, whether it's a room or piece of land, instead of just measuring how long it is. Okay, you can see some formulas. Square, you can say x is the one side length, so the area is x squared, x into x. So the triangle, you can see the basement is b and the height is h, then the area we can calculate as area equal to half into base into height. The circle, you can see the area is 5 into r square. Remember, not r is 2, 5r is for the all the circumference. Here is the uh, area we can calculate as 5r square. So the rectangle, we can see b and h, area equal b into h. The eclipse we can call as area equal 5ab, right? A is radius, b is like this, so 5ab. And the trapezoid we can call as a plus b. Yeah, this is b, right? A plus b divided by 2 into h, right? Trapezoid. Right, so now the rectangular area, when we call it as rectangular area, you can see here is the 1 square meter. Here is square meters length and 3 meters width. So consider a room 4 meters by 3 meters as shown is above. Here is a room. So clearly it can be divided up to 12 squares, right? You can see that can be divided up to 12 squares, each measuring 1 by 1. So 1 square is 1 into 1, right? Each square has the area of 1 square meter, hence the total area is 12 square meters, usually written as 12 square meters for the convenience, right? So to calculate the area of the rectangle, multiply the length of one side by length of the other side. Remember, to calculate the area of the rectangular, you have to multiply one side by one other sides, right? So then 4 meters into 3 meters equals 12 meters squared. Don't forget to write the meters squared. Okay. All right. So now you have a rectangle like ABCD. You can see if you have a rectangle ABCD, and you draw a diagonal from one corner to the opposite corner. Now you draw a diagonal from one corner to opposite corner that divides the rectangle into two triangles. Now you can see ABC. There's a triangle, and ACD also there's a triangle. So ABC and ADC. Now if you look closely, you will notice that these triangles are exactly same size and they are congruent. Now you can see when you draw the diagonal, and now these two triangles are congruent. Okay, so if you want to find the area of one of these triangles, you can use a simple formula as area equal one triangle. You can check the area 1/2 into base into height. Okay, so this works for any triangles, not just one inside triangle. But remember, when we say height, we mean the distance from the base to the opposite corner, right? Base to the opposite corner, right, measured at the right angle, right? It is not the height from here to here. We need to get the height from here to here. So whether it's a rectangle or any other shape, the area of a triangle is half the product of its base and its height. Remember, whether it is a rectangle or any other shape, the area of a triangle is half the product of its base and its height. So measured in square units like square meters. And here, school fact: if you have two triangles with the same base and they drawn between the same parallel lines, they'll have the same area. Okay, you can see from this diagram. Right now, we'll go to the area of a circular shape. So the area of a circular circle is given by the formula, right? How to find the area of a circle? We will find by A equal 5 into r square. So where the r is radius, or A equal 5 into d divided by 2 squared equal A equal 5d squared divided by 4. So if the diameter is given by r equal d divided by 2. Alright, so remember that any area is so many square units. So the unit of a circle must include the square term. Example, what is the area of a semicircle where the diameter is 30 centimeters, right? So this full circle, and now we're going to find the area of a semicircle. So in here the diameter is 30 centimeters, right? So now we calculate what is the area of semicircle where the diameter is 30 centimeters. Now the area of a circle we can calculate as 5 into d divided by 2 into square. So then we are going to find the semicircle. Now we need to divide this formula by 2. Then semicircle is half into 5 into 30 centimeters divided by 2 into square. So then the answer comes like half into 5 into 15 square meters, 15 centimeters square, and 353.43 square centimeters. All right. Right. Okay. Here you have some figures, right? Some solids. How to find the square, right? So you can see name of the solid is cube. Figure AAE. Lateral curve surface area is 4a square, right? Cube area we will find by 4a square. So a is side of cube, and the cuboid, here is the cuboid. We can calculate the area from 2h, h means height, 2h into L plus B. It means L is length, B is the breadth, and the h, right? And the cone, you can see here is the cone we can calculate as 5RL. R means radius, h means height, L means the slant height. Okay, right? Here is a right angle, then we have to find the slant height. How? From the Pythagoras theorem, right? So then the R is radius, and the height and the slant height. All right. And the cylinder we can get at 25R into h, 25R into h, radius of the base height. And the sphere we can call it as 45R squared. The area we can calculate as 45R squared R. And the hemisphere we can calculate as 25R squared, because this is the half. And the prism, perimeter of the base into height, right? Prism we can call it as perimeter of the base into height. And the pyramid can as half into perimeter of the base into slant height. Okay, slant height, we need to get the slant height. Okay, just remember this one very important, and just remember these formulas, then you will try to do the homework from these formulas, right? Okay, you can see the table below indicates some areas of many column shapes. So shape circle, we can area calculate 5R squared or 5D squared divided by 4. And the triangle, half into base into height. And rectangle, base into height. Square side, and the parallelogram, base into vertical height. Parallelogram we can take the area by base into vertical height. And the trapezium, half into sum of the length of two parallel lines into vertical height. All right. Okay, now we'll go to the calculation of areas of the shapes. Okay, calculation of areas of the shape. Sometimes when you want to find the area of something, sometimes you want to find the area of something, it's like it's not a shape you already know how to measure. It's like a square or triangle. It might be weird shape or made up of different parts stuck together, right? So in this case, you can still find the area by breaking the shape into smaller familiar shapes like squares, rectangles, triangles, or circles. If you have a very complicated structure, if you want to find the area, what you want to do, you have to divide these into the most familiar shapes like squares, rectangles, triangles, like this. So then circles, and then you find the area of each similar shape and add them up. Then you can find this each similar shape and then add together. Then you can find the total area of this complex structure. So it's like if you have a puzzle made up of different pieces, you find out the area of each piece, then put them together to find the area of the whole thing. So even if the shape seems tricky, you can always break it down and find its area using the shapes you already knew, right? So you can see the normal one, area of the formula square, two side squares, and rectangle equal length is the width, and triangle half into base into height, circle a into 5R square, and parallelogram a equal base into height, and the trapezoid a equal half into a and b together into height, and ellipse a into here the a radius into other radius into 5. All right. Okay, so now we'll go for example, an office of 8.5 meters by 6.3 meters is to be fitted with a carpet so as to leave a surrounding 600 millimeters wide around the carpet. What is the area of the surrounding? Okay, now let's go how to solve this one. With a problem like this, it's often helpful to sketch a diagram. if you have a problem like this, remember you must make a stretch diagram first, right? Don't going to make it from your mind. So now we will make it, right? An office, the office, the length is 8.5 meters and the width is 6.3 meters, and so to leave a surrounding of 600, right, with the carpet, so as to leave a surrounded 600 millimeters wide around the carpet. All right, you have to make it a carpet 600 millimeters wide. Okay, here is the carpet, is office. So now the area of the surrounded equal office area minus carpet area, right? So area of the surrounded area we have to calculate by, we have to find the area of the office, then we can minus the carpet area. So now the area of the office, right? Yeah, area 8.5 meters into 6.3, here the whole room area, minus 8.5 minus 2 into 0.6 meters. All right, 0.6 meters. Why? 600 millimeters is 0.6 meters, right? Here the width is 600 millimeters. So then how to calculate the carpet area? 8.5 meters into 2 into 0.6 meters. Here is the length, and yeah, 8.5 here is the length. Carpet area is 8.5 meters into 2 into 0.6 meters, and the width is 6.3 minus 2 into, why we calculate multiply by 2, they have two places, right? Here and here, right? 2 into 0.6 meters, and then this one, the all room area is 53.55 square meters, and the carpet area is, here you can say 7.3 meters into 5.1, then 53.55 square meters minus 37.23 square meters equals 16.32 square meters. Okay, you can go through this one. Note that 600 millimeters had to be converted into 0.6 meters. Okay, just remember, don't forget to include units of the answer example, square meters. All right, now we may need to find the area of an object, that is the combination of shapes. So in this time, this is a combination of shapes. So now in this case, the shape comprises a rectangle and semicircle. Shape is comprised with a rectangle and a semicircle. So then the rectangle has a dimension of 150 millimeters into 50 into 200 millimeters. So then the semicircle has a diameter of 50. The semicircle diameter is 100 millimeters. So the total area of the sum of the two individual areas is 100 into 150. 100 into 150, the square rectangle area plus the semicircle half 5r squared equal 15,000 equal plus 5 into 2,500 equal 15,000. Yeah, so the area is like this. Here area into semicircle, 100 into 150 equal 115,000 plus 5r squared. 5r squared we can say 5 into r squared, 50 into 2,500 equal 15,000 plus 5 3.142. We'll calculate like this, and then we can take approximately 785854. Then the all area of this diagram is around 22,854 millimeters square millimeters, right? All right, so now we'll go to the volume. Right, so the volume is about how much space an object takes up in three dimensions. Picture is a box or a tank. So it's not just a flat like a piece of paper. It's not like a flat piece of paper. It's like length, width, and the height. So when we talk about the volume, we are talking about filling up that entire three-dimensional space, right? So we measure volume using cubic units. So the cubic meters, cubic centimeters, or cubic inches. These units tell us how many little cubes could fit inside the object. Okay, you can see this is the cube. So now you have a box. See in the picture here, you have a box. To find the volume, you look at the three-dimensional. Okay, you can see the three-dimensional here, right? Three-dimension, length, width, and height. Okay, height and the length, and the length, height, and the width, right? You can multiply these dimensions together to get the volume. So for example, if the box is 4 meters long and 3 meters wide and 2 meters high, you multiply 4 into 3 into 2 to get the volume, which is 24 cubic meters. It's like snacking layers of little cubes inside the box. Each layer has a certain number of cubes. So you multiply that by the number of layers to get the total volume. Okay, you can see each layer contains 4. 1, 2, 3, 4 into how many layers? 3. So 4 into 3, 12 cubes we can make it. So here are 2 layers, right? Hence the volume is they have 2 layers, then the volume of the cube is 12 into 2, it means 24 cubic meters. So now if you have different shapes that not a box, finding volume might be a bit trickier. So you might need to be use different method of formula, but the basic idea is still same. You look at the 3-dimensional and multiply them together to get the volume. That's the key to understand the volume in 3 dimension. Okay. Alright, so these are the formulas for volume for different shapes. You can see the name of the solid cube. How to calculate the volume of cube? Volume is ax cube. So A is the side of a cube, and the cuboid, how to say, length into breadth into height, we can calculate as volume. And the cone, we can say 1 upon 3 into 5 r squared h. Okay, just remember this formula is very important. 1 upon 3 into 5 r squared. R means radius of the base, and the h is height, and the slant height is L. And the cylinder 5 r squared h, and the sphere you can see 4 upon 3, right? 4 upon 3 5 r cube radius, and the hemisphere 2 upon 3 5 r cube radius, and the prism area of the base into height, and the pyramid 1 upon 3 area of the base into height. Just remember these formulas, very important for you. And now example, what is the cube capacity for 2-cylinder engine with bore of 77 mm and stroke of 89 mm? Let's see. Here the bore is the diameter 77 millimeters, and the stroke height is the height is 89 millimeters. So now first we have to calculate the volume of the cylinder, area of a circle into height. So volume of one cylinder, area of a circle we can calculate as 5 into d divided by 2 into square, d means 77 millimeters, into height we can calculate as 89 millimeters. So the volume of one cylinder is 414,440 cubic millimeters, and the volume of 2 cylinders is 828,880 cubic millimeters. So note that in this example the dimensions have been given in millimeters. The volume would normally be given in cubic centimeters. So to convert into cubic millimeter, cubic centimeters divided by cubic 10. Okay, right. So then when you divide this number by cubic 10, then you will get 828.88 cubic centimeters. So when calculating the area or volumes, remember the volumes, but be ready to spot when an area or solid body is a combination of basic shapes and can be added or subtracted. Right? Yeah, that is the end of this lesson. Thank you very much for staying for this lesson. This is a little bit longer. All right, so this is the 4th lesson, and the next lesson I'm going to teach you about the graph. This is actually the 80 chapter, actually the module EASA B1 module number 1, mathematics, a little bit easy for you. So the basic thing is you just follow up and you study and you just do the homeworks, and then you can learn good. Alright, so the next lesson I'm going to teach you about the graph. Okay, let's see how to make the graph, and it's also a little bit longer, so stick with Aviation Engineering, and don't forget to subscribe Aviation Engineering, and don't forget to share these videos. It will helpful for your friends, your relatives, anyone who wish to sit for module 1 examinations recently. Alright, so thank you very much again, and we will see you on next lesson. Have a good day for all of you.